here again at your service with another, well, we hope to be a very enlightening math video because we are here, my friends, yes, for math. I have not come here for any other reason. That's right. My main objective is to provide you mathematics. And for you guys, your learning target, as you can see above, is to multiply decimal fraction with tenths by multi-digit whole numbers using place value understanding to record partial products. Whew, that's a big mouthful. Oh my goodness, where did this guy come from? I just now noticed him. My goodness, could he be any bigger? He's taking up the whole screen. But you know what? You're kind of cool looking. Is this an ankylosaurus? The dinosaur, the one that has that little ball at the end of his tail, and oh my goodness, he looks armored just like the crocodile. Yeah, I like him. You know what? He is going to be my new guard dog. Yeah, my guard dinosaur, just in case that pesky little rhino tries to come back again. Anyway, so again, our learning objective, let's go over that. Make sure we break it up in parts. Multiply decimal fraction with tenths, okay, by multi-digit whole numbers using place value understanding to record partial products. And you know, when we talk about partial products, we are indeed talking about the good old famous well-known area model. That's right. He likes his real name being recognized. Okay, well, let's go on to the next page. Here we go. Oh, you're back again. Oh my goodness. Hey, you're one nice fella. You know that? But you know, you're kind of big. I do like big guard dogs, but we're going to make it a little bit smaller, okay? I think just this size is pretty intimidating, to be honest with you. Okay, let's kind of put you up there. All right, let's take a look at what we have here. It looks like that we have 43 times 2.4. Okay, well, let's look at this first before we start going, I know what to do, Mr. Warrior, you need to multiply. Okay, we're going to actually just slow it down, okay? Slow on down. That's right. Let's first estimate the product. And we were talking recently about rounding. Remember rounding digits? And then we're making estimating, and some of us were a bit confused, kind of the difference. Very similar. Estimating means to come up with a quantity that does make it easy to add or subtract or to multiply. So when I look at 43 times 2.4 and I think about estimating, in a way it is like rounding. Because here, 43, let's just say, isn't that about 40? Yeah, that's rounding and estimating. And then I'm going to multiply that, well, 2.4, couldn't I say that's about 2? There we go. And then I can see I can multiply easily. We're going to get 80. Oh, maybe we can use this tail as part of the number. Hey, it's a perfect 0. Anyway, so now the question becomes, if we're going to go ahead and estimate this to kind of get an idea, the answer should be about 80. I'm wondering, do you think our answer is going to be greater or less than the actual product when we multiply? What do you think? Yeah? Is that what you're thinking? Okay. All right. Why don't I hear anything? Oh, that's right. This is not an interactive video. I apologize. Well, you know what I'm thinking? I'm thinking it's going to be less, right? If that's what you were thinking, woohoo, way to go. You're on your game. Because 40 is less than 43, right? And over here we have 2.4. Well, 2 is less than 2.4. So kind of logic says if we're starting off with smaller numbers, then our estimate should be lower. Seems good to me. I like it. Now, probably then we could say that because both factors were lower, that maybe the rounded answer is, or the actual answer might be closer to 90 rather than 80. But at least we have kind of a ballpark kind of picture here. So now what we need to do is we're going to go ahead and rename our two factors here. I'd like to rename 2.4 as tenths. This way I can remove the decimal. So I'm going to go ahead and decompose 2.4, as they like to use that word, decompose. I think of something like in my kitchen that has been on the counter a little bit too long. Like, you mean like that, Mr. War? Yeah, you don't want things to kind of decompose, on your kitchen sink. But anyway, that is the idea. This would be written as 24 tenths. So I could think of this as 2.4 as 24 tenths. Very good. Okay, so let's go ahead and use that area model, the thing that we've been using. Again, this is about to record our partial products. Okay, so let me go ahead and let's just show our 43 first. Since we do this one here, let's show 43. So I'm going to show this quantity here, since this is like the bigger box of my area model. That would seem like that should be a little bit larger. and then my 3 being a little bit smaller. I have 24, so let's go ahead and put the 20, this is right here, plus my 4, so that I have here. I mean, it's something we need to kind of keep in mind. Remember, we are using that unit of measure of tenths. Okay, so now I just have to multiply. So 3 times the 20 here is 60. Then over here we're going to have 12. Of course, 40 times 20, that's 800. And 800 again, simple facts, 4 times 2, 8, plus my 2 powers of 10. And then finally over here I have 4 times 4, which is 16. With my 1 power 10 gives me 460. So now let's go ahead and take our partial products here. We have 800, probably list that one first, and then 160. I have 60. Finally, I have 12. Now I can just add those partial products together, and I'm getting 1032. Now keep in mind, 1032 tenths. That's right. I heard you guys shout that out there. Mr. Ward, tenths. Yes, it is. Which then is going to be equal to, well, since we went ahead and removed the decimal out by renaming that as tenths, that basically means I'm going to bring that right back in there. So I'm going to get 103.2 ones, because when you look at that place value, blah, 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 when you look at that place value, you have tenths over here, and next door you have ones. Remember, and that's actually where that decimal point is. But what we did was we moved the unit from tenths to ones, so it was 1 power of 10. All right, we get 103.2. 103.2. Now in this case, it's going to be ones. All right, tenths was before we moved the decimal. Now let's compare our answer here with our estimation. Here we had 80. 80 is fairly close to 103, but remember we mentioned that it would have probably been a little bit larger because we rounded down, or we estimated down under the value of each one of these factors, so that would have been closer to 90. Yeah, that's very, very reasonable. Well, now let's solve this problem using the standard algorithm. So if we have 40, let's do our 2.4 times 43. And here, to remove the decimal like we did, we multiplied that by 10. So this is what we did the last time, remove that decimal. Let's do that now so that we actually have 24 times 43. Now we'll do the standard algorithm. Standard algorithm says that we need to multiply the ones, which is 12. I have to carry my 1. That's going to be added when we get to the tens column. Now we have 3 ones multiplied by 20, which really in reality is, right, 60. But we're just going to write 6, and then plus 1, 60. 6 plus 1 is 7. We'll put 7 here, because it's going into the tens column. Now we have to put in our placeholder. Very important to put in that placeholder because now we're moving from the ones column to the tens. Well, the tens, when we multiply that, 4 times 4 is 16. I carry that 1. Boy, another plus 1 up there. And now I'm going to end up with 8 plus 1 is 9. Now I need to add all those together because I never subtract when I'm multiplying numbers together. So we're always adding at the end. 13. And then we end up with our, looks like again, 1032. However, we have 1032. Well, in essence, we had multiplied by 10. So what we need to do is to make sure that we reverse that process to get our actual number back, we could divide by 10. And by dividing by 10, we'll then change that number to 103 and 2 tenths because the decimal place is moving one place to the left because we're dividing by a power of 10. I don't know. What do you think? So one key thing that we definitely learned here is that if you take any number like 2.4 and you multiply it by 10 and you end up with 24, but when we reverse that process, we divide it by 10, it brings us back to 2.4. And the key thing here is to learn is that we know what we're doing with that decimal point. All right, let's go to the next page. Cool. So now we have another problem. We have 3 and 5 tenths, 3.5 times 42. So again, we want to do what we did the last time is we want to go ahead and round the factors. Let's do that. After rounding, I came up with 160. Based on the 5 or more up to score, I rounded that to 4 and that to 40. So I have 160. Okay, let's go ahead and pull out our area model. Now this might be a good time to show too here where we have model with mathematics. That's basically what we're doing here. All right, so it says this is mathematical practice number 4. It says I can recognize math in everyday life and use math I know to solve everyday problems. So in this case, we're actually drawing concrete models. That's what you see right here. Look what we've done. Make assumption and estimate. We've done that. Okay, and so this is key to our learning. This mathematical practice number 4, modeling with mathematics, and this is what we're doing here. let's go ahead and set up our problem. So we want to do it, basically kind of do what we did the last time. Let's go ahead and put our 3.5. Let's go ahead and just, again, rename that into tenths. So now I can have my 30 plus 5 tenths here, or 30 plus 5, we actually say 35. And then over here I could have my, let's do the 40 down here, plus the 2 for the 42. Now I can go ahead and multiply across. Well, this is 60. Why does this look so familiar? Looks very familiar, doesn't it? This would be 10. Here, 30. We have simple facts. 12, 2 powers of 10. Easy way to multiply larger numbers without freaking out. Okay, and then 5 times 4 is 20, plus 1 power of 10 is 200. This is kind of interesting. What we could do this is to actually show it this way. So we have our 35 tens. We had her, and we were multiplying that by 42. Now, if we do this, you can see what's going to happen is we're going to end up with 70. That's 5 times 2, which is 10. Carry the 1 6. That's 70. Interesting that this right here, see, is also, that's your partial products. Your 60 plus 10 is 70. Now, if we go ahead and put in our placeholder, then we have 5 times 4, which is 20, right? So I'm going to go ahead and put my 2 down here, carry the 2 here. I put my 0 down there, put the 2 up there. Now I have 12, and then I have 2, which is 14. Interesting. 1200 plus 200? Yeah, 1400. And so now we end up with 1470, 1470. But remember that right now is still in tenths. That was the unit we were using. Now, we already know how to get that back, right? We take that 1470. We need to divide by 10 because we had multiplied by 10 here in the factor. And that's going to equal 147.0, or just 147 would be the way that it would be written. And what was our estimation? It was 160. Isn't that incredible? We were that close. Woo, yeah, we rock. We rock, yeah, 5th grade. Yeah, okay, that's you. All right, Mr. Wara, come on. Okay, well, we did it last time. Let's go ahead and rename our 3.5 into tenths so that we can get 35. So that means we are going to have to multiply by 10. And then we can multiply by that 42. Now we have whole numbers. Now we don't have to worry about the decimal for the time being. All right, now we have 10. Here's 6. I have 7. Placeholder. I need that placeholder. I do. Why do I need the placeholder? Because I'm moving over into the tens column. Now I have 20. Carry the 2. And then I'm going to have 3 times 4, which is 12, plus 2, which is 14. Pretty much the same thing that we did there, didn't we? We pretty much did do that. I know that's what you're thinking. Okay. Now I have 1,470. Remember, we need to divide that by 10 now to get into ones, which was 147. Okay, which is basically what we did there. Same thing. Why did I do that? I don't know. I guess I just did. I was trying to show the connection here, but now we just went ahead with the standard algorithm. Okay. All right, my friends. You know what? Oh, we have another page here. What's this? Oh, what is this? Oh, my guard dog. Now, live long. You stole my words right out of my mouth, buddy. My goodness, you're here for like a one day. You pick up this stuff pretty quick, huh? Hey, you know what, bud? Good for you. Well, I can't say it better than my friend did. Now, live long and prosper.